Here we've got 8 files and the size in megabytes of each file. And the files are to be stored on 50 megabyte disks. And we want, firstly, a lower bound for the number of disks. And then we need to find the best way to fit the files onto the disks. And that best way is going to use the first fit bin packing algorithm. Then we're going to do a bubble sort, then we're going to use the first fit decreasing bin packing algorithm. So let's get started. So the total of these numbers is 173, and the size on each disk is 50. So the lower bound is 173 divided by 50, which is 3.46. So the lower bound, write this out again, the lower bound is actually 4. It's definitely not going to be possible to use fewer than 4 of these disks. So we've got 4 bins, at least 4 bins, we may need more, and the algorithm says take the items in the given order, place each item in the first available bin that can take it. Start from bin 1 each time. So let's put 23 into bin 1. Will 29 go into bin 1? 23 plus 29 is 52, so it won't fit. We've only allowed 50 on each of these bins. The bin is the generic word, in this case it's a disk, but we'll talk about bins, it's a bin packing algorithm. So the next number is 11. Will 11 go into bin 1? Yes, because now 23 plus 11, that's 34, we've still got room. Next one is 34. Will 34 go into bin 1? No, that takes bin 1 over 50. Will 34 go into bin 2? No, that takes bin 2 over 50. So 34 has to go into bin 3. Next one is 10. Will 10 go into bin 1? So far in bin 1 we've got 23 plus 11, that's 34. 34 plus 10 is 44. Yes, we can't go over 50. 44 isn't over 50, that's okay. Whoops, I didn't mean to do that. I meant to write 10. Now 14. Well, we've just said we've got 44 here, so 14 is going to take bin 1 over. 29 plus 14 is 43, so that's okay. We can put bin 14 into bin 2. 35, well 35 won't fit into 1, 2 or 3, so that has to go into bin 4. And now 17, just fit 17 into one of the remaining bins. 23 plus 11 plus 10, that's 44, 17 won't go there. 43 plus 17, that's over 50, that's 34 plus 17 is 51, 35 plus 17 is 52, so 17 won't fit into any of these bins, so we do need a 5th bin, and that's going to have 17 in it. So that's parts A and B done. Right, now we need to perform a bubble sort, and we need to list them in descending order. And you need only write down the final result of each pass. Well, that's lucky, because it would be a lot of writing if we had to write down every single comparison we did. So the bubble sort says start at the beginning of the list, pass through the list and compare adjacent values. For each pair of values, if they're in order, leave them. If they're not in order, swap them. Now remember, it needs to go into descending order. So 23 and 29 is not in the right order. We want the biggest numbers first. So 29 swaps with 23. But 23 is bigger than 11, so you can put 23 in. Now we're comparing 11 with 34. That's not in the right order. We want the biggest numbers first, so we need to swap. So now we're comparing 11 with 10. That's okay. Now we're comparing 10 with 14. No, we need to swap them. Now we're comparing 10 with 35. No, we need to swap them. Now we're comparing 10 with 17. No, we need to swap them. So after the first pass, we've got 10, the smallest number, on the right hand side. Now let's go through again. 29 with 23, that's okay, that's descending. 23 with 34, no, that's not okay. We need to be in descending order. So 23 with 11 is okay. But 11 with 14 is not okay. 11 with 35 is not okay. 11 with 17 is not okay. 11 with 10 is okay. So at the end of the second pass, we've got two numbers. We've got the two smallest numbers on the right hand side. Let's go through again. 29 with 34, no, we need to swap. 29 with 23, that's okay. 23 with 14, that's okay. But 14 with 35, no, it's got to be in descending order. 14 with 17, no. 14 with 11, 11 with 10, and so on. Let's go through again. 34 and 29, that's okay. 29 with 23, that's okay. But 23 with 35 is not okay. 23 with 17, yes. 17 with 14, 14 with 11, 11 with 10, yep, that's fine. Let's go through again. 34 and 29, yep. But 29 and 35, that's in ascending order, and we want it in descending order. But the rest are going to be okay like this. And then finally we're going to get 35 and 34, and the rest are all in the correct order. Oops, that 14 didn't come out very well, did it? Let's try that again. And then the last thing is when a pass is completed without any swaps. So let's go through again. 35 or 34, yep, 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 this is all okay. So this is a pass completed without any swaps. And then it's very important that you write sort completed. If you don't put this at the end, you lose that final mark. So sort completed. Now we need to use the first fit decreasing bin packing algorithm to see to put these numbers back into the bins. So we know the lowest bound was 4, so we're certainly going to use 4 bins. Last time we had to use 5. Can we get away with 4 this time? So the algorithm says reorder the items so they're in descending order, and then apply the first fit algorithm to the reordered list. That's okay. So let's put 35 into bin 1, that's okay. 34 won't go into bin 1, but it will go into bin 2. 29 will have to go into bin 3, and 23 will have to go into bin 4. Otherwise, the total in the bins would be over 50. 17 won't go into 1, because that makes 52. It won't go into 2, that makes 51. But it will go into bin 3, that makes 46. 14 will go into bin 1, that makes 49. 11 will go into bin 2, won't go into bin 1, but it will go into bin 2. 10 won't go into 1 or 2 or 3, but it will go into 4. So we do need only 4 bins if we're using the first fit decreasing algorithm.